What's up, my dudes? So, this is going to be the first chapter of A2. Let's start this off with a bang. This chapter is called Circular Motion, and with regards to your syllabus, this does not have a lot of questions that are asked individually related to circular motion, but the idea is that circular motion and the concept in itself is used in a lot of other chapters. So, if you don't get this straight right away, then this will always bother you for the remainder of the A2, right? So this is, as the name says, is all about objects which are moving in circles. So we'll be quantifying that sort of motion in terms of the forces, acceleration, and we'll be talking about how we can see those examples in real life. So right here I have something for you from the Olympics, and this is something called the hammer throw. Looks pretty exciting. Now let's have a look at the video.
The final of the men's hammer would have a fairy tale ending, underlining how the Olympic Games can reward persistence. And for one country it would be an historic occasion. This was a wide open contest. The exit of favourite Pavel Fajdek of Poland in qualifying encouraged the others. Notably Dilshod Nazarov from Tajikistan. This his fourth Games. He hadn't finished higher than 10th before, but this time he led at halfway. The competition was about to hot up. Could Nazarov handle the pressure? Ivan Shikan from Belarus tried to knock him off top spot, but this effort would only be good enough for the silver medal. Nazarov was enjoying the challenge and extended his lead. Showing superb balance, timing and power.
By the way, the guy in green won. So you could see that those guys obviously were built like tanks as well, but also at the speed, the speed at which they were spinning prior to releasing that hammer, right? So I know it doesn't look anything like a hammer, but it is actually called a hammer. So what did we learn from this video, aside from the fact that shouting at things can make them go faster? So we can see that when the guy here was spinning that hammer, he did so in quite a number of turns, and after that he let that hammer go. Now this is also a very important concept, that where did the hammer fly off? Because we know that if someone like you or me, who is obviously inexperienced at the sport, if they let it go, then maybe it could have just struck the hammer then maybe it could have just struck the camera that we are watching this video through. So this also obviously requires a lot of skill, but anyway, one thing we noted was that whatever circular path was being traced out, as soon as he let the hammer fly, it went off in the direction it was last moving in. And this is a very important concept and something we have to remember for our studies as well. Now let's go on to the next video. Now this video is approximately 14 years old as far as I remember, and this is something that we've all dreamt of doing as kids. Now I won't foil the fun for you, let's just go on to the video.
This is it. This is it, we're going in too fast. And here we go.
Alright then. So now obviously this very happy guy risked his life to give us this video 14 years ago, and he wants us to learn something from this. So what did we learn here? If I talk about this looping the loop, right, something which is a subject of a lot of interest, especially in racing movies and whatnot, apparently defying the laws of physics, but this is not a movie, no CGI here, no extra effects, no budget which is used in the filming of this video. So this guy apparently looped the loop, right? He went through a circle and he did not fall off, thankfully enough for him, and he completed the loop. Now, how do you identify and how do you actually talk about this idea as to what is the minimum speed that we should have in order that we do not fall off? Now, obviously, all of us know from experience that the riskiest point was right at the top of this loop. So let me bring back the video to that point.
And here we go.
So we can also see here that the car was the slowest at this point. So we know that our speed should be enough that we do not fall off from here. Now, this is something that a lot of people think in a case like this, is that we only need to have some speed so that we do not fall off. We need to have some speed. But this actually is not correct. Because even if you have some speed at this moment, it could also be the case that you fall off like this and break a neck. So how do we actually stay in contact with the track and complete this loop? This is also something that we will be talking about in this unit. Now on to the last one. Now we'll be looking at another wonder of physics, and what will be happening is this guy here will be spinning around some water in a bucket, and miraculously enough, this bucket would not have the water filling out even when the bucket is right on top of his head. Now let's have a look at this video.
Wow, the water does stay in the bucket.
Yes, it does.
But the question is, why does water stay in the bucket? I mean, if I just hold the bucket upside down, water will flow out of the bucket, right?
Go ahead. Prove it.
Okay. Why not?
Nice.
So here, don't be like this guy. Teachers already shower before coming to class. So what's the idea here? Again, we saw that if I take this video back to that point,
I mean,
even at this point, the bucket still contains the water and it does not fall on top of this guy. And again, this has to do a lot with the idea that we just talked about when we were talking about the car looping the loop. And this is the same concept which is applying here. Sounds cool? So that's exactly what we'll be talking about in this unit. So stay tuned and watch the next videos related to this unit to find out the answers to these questions.